Okay, so let's just do a little review. So on number 12, so if you've already done these questions, great. If you haven't, then let's just do them together. So it says the word product has been spelled using letter tiles and illustrations shown below. So kind of like Scrabble tiles. Okay. Using only these letters, determine the number of 4-letter arrangements if the arrangement, and then there's your conditions. So because it says 4-letter arrangement, we need to draw in 4 blanks. Okay, so 4-letter arrangements, so 4 blanks. So for 12A, has any letter in any position. In other words, there's no restrictions. So in the word product, how many Scrabble tiles is that? 7 tiles, right? So you've got 7 choices for the first tile, then 6, then 5, then 4, right? So once you've used the O tile, you can't use it again, right? And this is just fundamental counting principle or blanks method, and you just multiply the numbers in front of you. So I'm not going to go ahead and do the multiplying. We're just going to show you the setups and go from there. So part B, it says it has to begin with PR. So the first 2 blanks have to be a P and an R. So how many P's do you have in the word product? 1. How many R's do you have in the word product? 1. So you've used the P tile and the R tile. So how many tiles do you now have left? 5. So 5 times 4. Okay? So these are what we would call your restrictions. So you always fill in those first and then fill in the other blanks around it. So part C has 2 vowels in the middle. So this has to be a vowel and this has to be a vowel. So remember your vowels are A, E, I, O, U. So in the word product, how many vowels do you have? 2. So you've got 2 choices for the first vowel and then 1 choice for the next vowel. So you've used the O and the U. They've been used. How many tiles do you now have left to pick from? 5. Right? Because in the word product, so you've used the O and the U, right? That's the vowel. You've got 5 choices left, and then 4 for that one. Now notice, every time I add in a restriction, depending on what the restriction is, the number will go down. Okay, so this is no restrictions, so this is the biggest answer possible. Every answer after that will be smaller than this number from A because it's got restrictions. Has 2 consonants in the middle. So consonant, consonant. Okay, so how many consonants do you have? So consonants are the non-vowels. So how many consonants do you have to pick from? 5. So let's say we pick the letter D. So D can't be used again. So now how many consonants do you have to pick from? 4. So let's say you picked an R. How many tiles do you now have left to pick from? 5 and then 4. So notice the way I thought about that, right? I did this tile first, this tile second, this tile third, and this tile fourth. But yet when you write it out, it's just 5 times 5 times 4 times 4. Okay? So when you look at the multiple choice answers, if they're written like 5, 5, 4, 4, I don't want you to solve it as 5, 5, 4, 4. I want you to solve it as 5, 4, 5, 4. Right? So when you look at these questions on multiple choice, just put your hand over the multiple choice and solve it how you would normally solve it, then reveal. Because otherwise it might mess with your head into how you actually attack the question. Is this bringing back memories? Okay, so let's look at number 15, 16, and 17. So these are just like the multiple choice numeric response. So it's similar to what you're going to get on the diploma. Okay, so on 15. So it says, in the final of a 100-meter race, there are 8 competitors. The number of possible ways in which the gold, silver, and bronze medals can be awarded. Okay, so How many blanks do we draw? 3. Okay. So this is gold. This is silver. This is bronze. Okay. How many runners do you have to pick from to get gold? 8. So let's say Joey gets first. How many runners do you now have left for silver? 7. Say Anne gets silver. And how many choices left for bronze? 6. So notice on this question, all they did was give you 4 answers, A, B, C, and D. So if you did this and you didn't get out A, B, C, or D, you're literally going to have to take a random guess. Because there's nothing, you can't go backwards from A, B, C, and D. You can't go backwards from those 4 numbers. You just have to hope that you have done it right. Okay. Okay, so let's look at number 16. How many even 5-digit numbers are there? Note 3, 1, 2, 4, 8 is acceptable, but 0, 1, 2, 4, 8 is not. So what is that implying? First off, how many blanks? 5, because it's a 5-digit number. So what is the problem with 0, 1, 2, 4, 8? 0. So we can't have 0 here. What's the other restriction in this question? It says how many even numbers. So that means it has to end in an even number. Okay. So remember our digits go from 0 to 9. So there's 10 digits, of which 5 are even and 5 are odd. Okay. So how many choices do I have for this last number? 5. Okay. So what I suggest you do here, for some of you, this might be helpful. Okay, pick one of those numbers out that it would end in. Which one do you want it to end in? Nope. Oh, yes, 0. Okay, so it's going to end in 0. Okay, so we've picked 0 because it has to be an even number. Okay, so cross out 0, 2, 4, 6, or 8, whichever one you want. Okay, now, oh, no, I don't want to do this question. Because if it ends in 0, that's going to change the opportunities for it to not start with 0. But if it doesn't end in 0, it changes this number here. That's well beyond 30-2. Okay, we're not going to do number 16. We're crossing that one off. Sorry. Okay, let's look at 17. So Sandra's taking an exam which consists of 2 parts, A and B, with the following instructions. Part A consists of 3 questions and the student must do 2. Part B consists of 4 questions and the student must do 2. Part A must be completed before starting Part B. At the end of the exam, the student has to list the order in which she attempted the questions. The number of different possible orders is. How on earth do we do this question? So, Part A has to be done before Part B. Okay? How many questions do you have to do in Part A? 2. So 2 blanks. How many questions have to be done in Part B? 2. Okay? Now, last week, we talked about the difference between the word and the versus the word or. So listen to my wording. Do you have to do Part A and Part B? Or do you have to do Part A or Part B? And. So that means we're going to multiply these 2 answers. Okay? So for Part A, how many questions do you have to pick from right from the start? 3. So let's say you pick question number B. How many choices do you have now for the second question in part A? 2. For part B, how many questions do you have to pick from for the first question that you have to do? 4, right? Because there was 4 questions. How many questions do you have to pick after you've picked the first one? 3. So it's just 3 times 2 times 4 times 3. Now, I wanted to illustrate this question mainly because of the length of the question, right? You see all those words and it's like, but if you take the time to do this and remove all the words, it makes the question substantially easier. Okay? So when you're reading these questions on the diploma, just slow down. Take a minute. Instead of trying to like do everything in your head, literally stop and write out part A, part B. Right? Well, how many blanks do I have for part A? How many blanks do I have for part B? And literally go through it very, very methodically. That will be the difference between doing these right and not doing them right. Because at the end of the day, numeric response, you just have to hope that you've done it right because there's no comparing it to anything. Okay? You'll know if you do a numeric response wrong if you end up with a negative number or if you end up with a number more than 4 digits. You'll know you've done it wrong. But if neither one of those things happen, you just have to hope that you've done it right. At least with multiple choice, you have a 1 in 4 shot of guessing correct. Okay? The odds of you writing down a number and that number happens to be the right answer, slim to none. Okay? Okay, and then the other thing we talked about last day was factorial notation. So if I gave you the number 5 factorial, 5 factorial means 5 times 4 times 3 times 2 times 1. Factorial is just a way of writing out something shorthand. So if your blanks are all counting down by ones, you can punch in 5 times 4 times 3 times 2 times 1, or you can just punch in 5 factorial. Where that button is on your calculator, if you hit math and then hit go over to PRB, so hit math and then go over to prob or PRB, number 4 is where you'll find the exclamation point. Okay. So what I'm going to do with you today is I'm going to show you button number 2. So button number 2 is NPR, and then we know the factorial. Okay, so I'm going to show you both of those today, and we're just going to work through it. Questions on anything that we've been talking about so far? They're word problems, right? It's a word problem unit. My best advice to you is just to slow down and just think about the conditions of the question. I did mention this to you last week, but you've probably forgotten. The first part of this unit is substantially harder than the second half of this unit. So we do the much harder stuff right now. The much easier stuff is at the end of the week. Okay. Okay, I handed out this page to you. It's technically written at the bottom of page 75, but bottom of page 75, they don't write it as prettily as what I've got it here. So this just looks a little neater. So word of the day is permutation. Okay. Permutation is an arrangement of objects in which the order is important. So it's an arrangement where the order is important. Okay. So that's just so essentially all these questions that we've been doing, so lesson 1, every question that we just did was a permutation. Every single one of them. Right? Because I was rearranging the letters of the word product. I was rearranging my 10 digits to get out an even whole number. I was rearranging part A, part B questions to get a specific order. Anytime there's order, it's called a permutation. Anytime. So the way we solve them, you've got 2 choices. First one is the blanks method. Now, This is the method that I prefer because we've already practiced it in lesson 1. You didn't even know that you were doing a permutation and you were able to do lesson 1. Okay, so Blank's method works for all permutations. Okay, the key is you have to do the restriction first. The new way is this NPR, and that's what we're going to focus on. Sorry. So what the NPR is, N stands for the number of objects, R is the number that you are arranging. So in the word product, if I have the word product and I'm doing 4-letter arrangements, that is 7 tiles, P4. So I have 7 tiles for the word product, and I'm arranging 4 of those tiles. Here's my issue with NPR. I have a couple of them. You can only use on the basic questions. What I mean by that is the blanks have to be counting down by ones. Or in other words, no restrictions. Now look, the diploma only gets 4 questions for this whole unit. 4 or 5 questions for the whole unit. They are not going to give you a permutation question unless there's a restriction involved. They're just not. So as soon as we start bringing in restrictions, your blanks aren't going to count by ones now. It's going to be like an 8, 7, 7, 5 or 5, 5, 4, 4. Those blanks don't count down by ones. So if the blanks don't count by ones, you can't use NPR. Okay? So the examples I'm going to do with you today, I'm going to show you how to do them with the blanks method and how to do them with the NPR. Here's what I need you to know, is that if you get a question on the diploma and you solve the question using blanks method, but all the ABCDs are written in NPR, but you solved it this way, but the diploma has it written this way, and you don't understand this way, you're going to take this and plug them into your calculator. And you're going to figure out which one matches the blanks method answer. It's a hoop you're going to jump through. Okay? I prefer the blanks method. Here's why. It works with every single question. The NPR only works if you have the blanks counting down by ones and there's no restrictions. That's almost nil of the questions. It's just not probably going to happen. Okay? But I'm going to go through the examples with you, but honestly, just do the blanks way. It's probably going to be what works for you 99% of the time. Okay? Okay, so on the bottom of page 75, sorry, I didn't mean to flip the page there. Bottom of page 75. It says here, an internet site access code consists of 3 digits. Knowing the 3 digits is not enough to access the site. The digits have to be entered in the correct order. The order of the arrangements of the digits is important. So because the order matters, this is a permutation. So for example, if I said, okay, it's a 3-digit code. The 3-digit code is 518. It's those 3 numbers. Okay, it's 518. Do you understand it could be 518, 581, 815, 851, 158, 185. There's 6 different actual codes that it could be. Just knowing the numbers is not enough. You have to know what order to put the numbers in. So when it's an order matters, it's a permutation. Okay? So it says list all the arrangements that John could use. Oh, they have the numbers 357. Okay, so let's just go with 357. So we got 357, 375, 753, 735, 573, 537. So there's 6 possible codes. So how would you do this question if you didn't want to list them all out? Okay, well, Blank's method, the code has to be 3 numbers long, right? How many choices do you have for the first number? 3. It's either the 3, the 5, or the 7. How many choices for the next code number? 2. And how many choices for the last one? 1. What's 3 times 2 times 1? 6. Now, let's apply this to what we just did. Do your blanks count down by ones? Yes. So it would be, you've got 3 numbers to pick from, and it's a permutation of all 3 numbers. So it's 3p3. So on your calculator, what you do is you hit the number 3, you go math, probability, pick number 2, and then you hit the number 3 again. And you get out 6. What's wrong? Okay. Yes. Yeah, so if you're running a if you're running a TI-83, your screen will go 3 NPR 3. But it knows that the 3 goes with the N and the 3 goes with the R. Pardon me? And it's still doing that? Huh. Okay, well, whatever. No, I thought it was only the 83s that did that. That's weird. Maybe I'll try and update your calculator at the end of class and see if that changes anything. Okay, so for me personally, this makes way more sense than that one. Just for me personally. But if this is the number of objects you have, and this is the number that you're arranging. So it's up to you which way you do it. My point is, if the ABCDs are all written like that, but you solved it like this, you're just going to punch that into your calculator and match up the answers. That's it. Don't let it freak you out. Okay. Okay. So we've already done that one. Okay. Whoops. We've already talked about that. Okay. So you can thank Mr. Hughes for the graphics on these slides. I just stole them from him. I didn't feel like remaking them. Okay, so permutation. So this is now on the next page. We're just going to kind of work through these examples together. So it says list all the arrangements of the word cat. Okay, so again, it's arrangements. So every time I change the order of the letters, I get out a new arrangement. So this is a permutation. So we've got CAT, CTA, TAC, TCA, ACT, ATC. So there are 6 arrangements. So what would this be in permutation notation? We have 3 letters, and we are arranging 3 of them. 3P3. It's exactly the same as the security code question from the last page. Okay. Now, on your formula sheet, you're given this formula. That. Now, when you punch in 3p3 onto your calculator, the calculator is actually doing this formula instantaneously. It has it built in. Okay. So 3p3, what we would do here, so this is my n. So the n goes into those two spots. The r goes into that spot. So if we plug those numbers in, we would have 3 factorial over 3 minus 3 factorial. Don't freak out. Now we learned this last week. What does 0 factorial equal? 1. So this equals just 3 factorial, which is 3 times 2 times 1, which is 6. On a question this easy, is it just worth your time just to list out all the arrangements and then write down 6? Yes. But what if I wanted you to do the word platypus? You can't list out all the arrangements of platypus. You would need to have a formula to go with that. And that's where permutations come in. Is there a shortcut? That's all they are. You do not have to have this formula memorized. It's just what the calculator is doing. Okay? So I just wanted to show you that. So when it says write it in factorial notation, that's what this is. That's plugging it into the formula. Now, I didn't see any questions like that on the diploma at all because they know you're just going to punch it into your calculator. So, okay. Determine the number of permutations of the letters of each word. Regina. So imagine these are all on Scrabble tiles. And when it says determine the number of permutations, that means you're going to use all the tiles. That's what that means. So if you want to do this by the blanks method, Regina has how many letters in it? 6. So how many choices do you have for the first position? 6. So you've picked the letter G. You can't pick G again. Now what? 5, then 3, 2, 1. So there's nothing stopping you from plugging that into your calculator. 6 times 5 times 4 times 3 times 2 times 1. But what you should recognize is it counts down by ones. So you could just use the factorial button. And if you didn't want to do blanks, how many objects do you have? 6. How many are you arranging? All of them. No matter how you punch that in, 6, 5, 4, 3, 2, 1, or 6 factorial, or 6p6, they will all give you 720. The math in this unit is easy. It's just recognizing the math that you should be doing. That's the tricky bit. Okay. So how many letters in Kelowna? 7. So again, it's going to be 7, 6, 5, 4, 3, 2, 1, or 7p7. Does that make sense? Okay. Oh, I don't want that. Okay. So here's that formula. So let's say it says use the fundamental counting principle to determine how many 3-letter arrangements can be made from the word graphite. So again, think of graphite as each letter is on its own Scrabble tile. So how many Scrabble tiles do you have? 8. Okay. So you're looking for how many 3-letter arrangements? So how many blanks should you draw? 3. So how many Scrabble tiles do you have to pick from for the first blank? 8. So let's say you use the letter P. Then how many Scrabble tiles do you now have left in front of you? 7. And then how many? 6. 8 times 7 times 6 is whatever that answer is. Easy. Here's the other way you could do it. You've got 8 objects. You're arranging 3 of them. 8p3. 8p3 is the same thing as saying 8 times 7 times 6. That's all you need to know. So, if this was a question on the diploma, which is a fair game question on the diploma, if you did the question like this, and you get out the correct answer, the A, B, C, D are probably going to look like this. 8p3, 3p8, 8c3, 3c8. Now, I haven't taught you what the C stands for yet. That's coming. But let's just say we know it's not that, not because you don't know what C stands for, okay? But I want you to understand why that is impossible. The first number is the number of objects you have. The second number is the number that you are arranging. Is it possible to arrange 8 things if you only have 3? And because you see the word arrangement in the question, it has to be a P. The key word for the C, the word is selection. So if you're selecting, think about it. If I want you 3 to come with me to create a group, I need you, you, and you. I'm selecting you, right? So out of the 8 of us, I need you 3. So it would be 8C3. Because it doesn't matter if I pick Amy, Kaylee, Kaylee, or Kaylee, Kaylee, Amy, or Kaylee, Amy, Kaylee, Kaylee. Like, it doesn't matter. As long as I end up with the 3 of you, the order doesn't matter. So the order doesn't matter. The order doesn't matter. So when you have a C question, the order doesn't matter. When you have a P question, order totally matters. How do you know the order matters? Because you're doing an arrangement. If I need the 3 of you to line up in a photo, if one of you were to move positions, would it create a new photo? Yes. That is an arrangement. So those are the P questions. So towards the end of this week, we're going to do the C ones. And then the tricky part to this unit is this. I'm going to start hucking questions at you. And you have to decide if it's a P question or a C question. Because we're going to scramble it up. That's the hard part to this unit, is figuring out which one you should do when. But for the purposes of the next few days, all we're doing is the P's. Okay? Okay, we've got just a couple examples left after the bell. We've already talked about that. We'll pick up here when we get back. Yep. Okay, let's just do a couple examples, then we'll call her good for the day. Okay? So this is example number 6. It's on the next page. Yep, page 77. So it says, in a region, vehicle license plate consists of 2 different letters. That word is important. Followed by 4 different digits. If the letters I, O, Y, Z are not used, how many different license plates are possible? Okay, so if I have the license plate CR3125, is that different than RC5213? Yes. So the order of the numbers and letters matters. So because the order is important, we call this a permutation. Okay? Since it's a permutation, we can use the fundamental counting principle. You can only use the blanks method on permutations. Okay, so we have 2 letters followed by 4 digits. Now, because it says different, this implies no repeats. Okay. Also, we're not allowed to use I, O, Y, or Z. So, how many letters are there in the alphabet? 26. But we're not allowed to use 4 of those letters. So how many letters do we actually have to pick from? 22. So we've got 22 choices for our first letter. The letters must be different. So how many choices for the next letter? 21. Now, is there any restriction on the digits? Only that they have to be different. So how many digits do you have to pick from in total? 10. And then they have to be different. So 9, 8, 7. Now, to me, I think what I like about the blanks method, which is fundamental counting principle, this is common sense. Like you're laying it out the way you think about it. Whereas the permutations way, you're going to do the letters and the digits. So we're going to multiply. So do you notice that this counts down by ones? And then this counts down by ones. So because they count down by ones, we can use the permutation way. So for the letters, how many letters did you have to pick from? 22. And how many letters did we actually pick? 2. How many digits did we have to pick from? And how many digits did we pick? If you punch this in, and if you punch that in, they will get out the same answer. Now, to me personally, that is not instinctual at all. Whereas this absolutely is. But that is that's my preference in there. Okay? I had kids last semester always do this. It made sense to them. They are not my people, but that's okay. It made sense to them, and so you do you. Okay? Whatever makes sense in your brain. Okay? So, on the quiz tomorrow, for lessons 1 and 2, I'm going to be encouraging you to do them this way, but if you do them this way, that's fine. I've got both answers written down on my page. So it doesn't matter to me which way you do them, but it's just going to be a little quiz on just random permutation questions is all it is. Okay. So in terms of the assignment, it's 7 and 8. And then 10, 11, and 14. So don't do 9. Don't do 12 or 13. And then 14. Okay, so let's give you about 20 minutes to work on these questions. And then we're going to move into the first type of special permutation question. It's a super easy one that we're going to stay with today. It's what happens if the word has repeated letters, like Mississippi. How do you deal with that? No,